Hello YouTubers and SSG followers. This is my 16 charging procedure. 4 charging procedures to go. But anyway, I have some result to tell you, and the results are following. You see here my measurement equipment. This is the voltage of my charging battery, and this is the amperage of my charging battery. I'm actually measuring here milliamps. I show you these values first because I did not start my system yet, but look at the voltage level which I have on the battery which I previously discharged. So I took 250 milliamps, put on the battery, and you see the result of after some. It was not complete 20-hour discharge procedure, but it took like 6 hours or 7 hours, and my resting voltage was at that level, so it's pretty good resting voltage. But I report you that my battery did not reach the COP1, so I see some voltage increase after the discharge procedure, but I cannot tell you yet if I got the full capacity of the battery. I mean like 5 amp hour. My maximum amperage which I got through discharge procedure was like 2 amp hour. So I am not at the point to claim that I have COP more than 1, but anyway, see very steady changing of my voltage of my battery. And on other side you clearly see here the result of my primary battery. Primary battery I charged conventionally 20 hour, and the voltage is 12.82 of my primary battery, milliamps 000. And with further ado, I should mention this is not over a Unity system, because I spent some money to charge my primary battery. But anyway, what you should know, I charge my charging battery by the impulses which my circuit produce when the magnet passes the coil. So now I start the charging procedure. You hear the self-oscillation noise, and you see how many milliamps it drawing. This is not actually mode in which I run my system. So what I do, I disconnect one of the cables from my circuit to the primary battery like this, and immediately no drawing of the voltage of the current happens. Then reconnect once again the circuitry right now, so the system is ready for run. And now I can move the view. Okay, now you will start to see some changing of my charging battery. So the voltage is increased as expected. You see that I'm getting currently 1540 milliamps to charge my battery, but this current is not enough to charge my battery to the full capacity. But on the other side I have here my primary battery voltage 12.76, and the amount of milliamps which I currently spent to run the system, it's like 32 milliamps. So it's running. Actually it's running at currently it takes much more milliamps as I expect, but it will stabilize later, like in 5 minutes. It stabilized to 27 milliamps power drawing to run the system. But other side I will show you. Okay, I should mention once again, I'm showing you my charging procedure, and I show you this as some sort of evidence that you can charge actually battery by the radiant type of impulses. it takes like 24 hours and sometimes even more to charge the battery to the full capacity. But how I measure the capacity of the charged battery? Using the C20 procedure. Always after charging procedure I put load onto the battery, and this happens separately from my circuitry here, which you are actually watching, and the discharge procedure happens under the due to controlling device. So I never damage my battery, I never discharge my battery below 11 volts. I'm actually always stop my discharge procedure when I reach voltage level like 11.66 or 71. So I will I care my battery as I can do, and I use my battery in very safe levels. But you see clearly I have on both sides the same battery as primary and as a charging battery. It's a 12 volt 5 amp hour battery. One battery always charged by conventional means, and other battery charged always by non-conventional means. And you see the voltage is increasing. This is not rapid voltage increase, but it's steady voltage increase. So after each charging procedure I see that my resting voltage is always higher as it was previously. So something happens to the battery chemically, and this is actually very good behavior of the battery when I even after the discharge procedure see the high voltage as it was previously. So for me it's like win-win. I actually showing you my side that I'm actually happy with the result. What has not really happened to me, I'm not saw the COP more than one, but I see clearly some charge. I can get some amps from my charging battery. So for charging procedures to go, and I expect that my results will be at the end of my whole series of charging procedures better. I hope I will get as a result of my charging and discharging procedures like 14 or 15 volts on my charging battery, and these volts are actually will be the sign that my battery can give you more amps as you actually expect. But in all of my charging and discharging procedures I never saw this, because it is like it is battery charging, but I'm not sure how capacity of the battery is actually can I get when I discharge the battery. So anyway, it's very cool project. Let me show you my primary side. So you see currently not 45 milliamps. I'm running my system. It's the spinning of the wheel is stabilized, and the amount of current which I get to run the system is like 26-28 milliamps, and voltage level 12.72 on my primary battery. So this is actually two devices which are showing me the information about the voltage level of the primary battery and about the current which I spent when my primary battery hooked up with the circuitry. So this is actually how much I spent to run the system, 27-28 milliamps. And maybe I will show you in the future the amount of impulses which I get on my system, but currently I have no time for this. If you like, just post to my YouTube video, and I will do this as next, and I show you how much radiant impulses I get on my system. But this is anyway a cool project. I should mention that on the EnergyScienceForum.com, which is administrated by the Aaron Murakami, I found and I read good books about the Bedini project, and the new released book the new released book by the Aaron Murakami and Peter Lindemann. It explains a lot of advanced information about how you can actually run the system, because once again I have only one transistor, and the people who are released more advanced information about the Bedini project, they are actually working with the 7 transistors, and amount of the coils in the advanced project are like 2, and the second coil is not connected to the circuitry. It's like how should I put this? The secondary coil is used, but the amount of the current and the voltage is separate from the circuitry. So very interesting, and I'm actually thinking about to build better advanced system in the next year, but I cannot promise you anything about this if I show you this or not, because I must build the system. Problem, always a big problem when you're building such system, that you actually know where the difficult points. So it take time to build very appropriate system, and in my thinking I need more research information currently on the batteries. So I will look forward to the future, how my project will develops, but I will always mention the battery is important. I think it's one of the most important parts of the system, because the circuitry itself, it just only need to trigger special signal which can be absorbed by the battery, and after that a big question arises, how battery behaves after you charge it by this non-conventional means. And this is pretty damn thing, because some people's using old junk batteries or not suitable batteries. And what I mean by that, my batteries have these openings where I can put distilled water, and you probably see always the sealed lead acid batteries. They are actually not so suitable for this type of the project, because at some point you just need to monitor the state of the liquid in the battery. But anyway, you see the battery is charging. On the other side I don't see any big discharge. I charge my battery very good. It's like 12.71, so it's showing me that the battery is with a good charge, and yeah, it's very good result. And this here I'm actually seeing that the voltage increase happening. It's not rapid, but it's still happening, I see. And if you just interested enough, when I disconnect the battery from the circuitry, okay, immediately lights the protection. This is a neon lamp with 230 volts, so 230 volts should running through this lamp. When it's not running, then you not see then your system probably don't work pretty well. My system work well, and you see the voltage decreases. This is actually a good sign. It means the battery is not charged. But when I put immediately the circuitry, when I connect my battery to the circuitry, I see the voltage increase, so pretty damn good. And yeah, it's like charging, not rapid charge. Remember, these impulses which I produce with my circuitry, they are actually moving ions in the battery plates, and the ions are moving from one battery plate to another. Then it means the battery charging. The charging process happens chemically. But what I should show you, my transistor is not hot. Is actually some little bit cold, but not so cold, and I can actually hold this like for many times. So it's my system running very cool. I don't use a lot of amps. Why I need so much amps? I don't think that I need a lot of amps to charge my battery properly. And by means which a battery is charging, the battery actually charged by the impulses which I produce with my circuitry. So I run my system like that. Less current, more some spinning of the wheel, and the amount of impulses very high, which I get from the coil. And this is actually thing which I will always repeat. You need to observe the impulses which you get from the coil, and if you catch a lot of impulses for a less power consumption, because I showed you at the start the self-oscillation mode. The self-oscillation mode produces a lot of impulses, but it takes more current from your circuitry, and this is not the way how you should run the system, because the spinning of the wheel helps you to minimize your power losses, actually, if you think about this. But I run my system like this, and I see that each discharge procedure gives me the resting voltage on the discharged battery even higher than it was previously. So charge, discharge, absorb the voltage, and if you see some increase, then I probably say that you're on the good path to reach the result which you actually want. And I want to charge my battery to very high voltage, like 15 or 14 volts, if it's possible. I don't know, but then I should expect that my battery actually work even better. So we'll just wait for the result as it goes. But you see, if you saw all my videos, if you took enough time, that each charging procedure, the resting voltage is always higher than it was previously. So something chemically happens in the battery, and the battery start actually produce good results. And I should mention, I do not use capacitors in my circuitry because I do not have additional time to develop or to use a ready controller for the capacitor discharge. Because if you use a capacitor system, you need to have some circuitry which will control the capacitor discharge levels. And Bedini actually selling such things, such charging systems with the capacitors. Sorry guys. It's commercial products, which I mean it's like Bedini charging devices, and they are producing the capacitor discharge technology. I will say this like this. It is not any secret anymore, but what I want to tell you, that it's possible to charge the battery with a Bedini type circuitry. It takes some time to set up the circuitry to that level that you produce a lot of impulses with a less current consumption, but it is possible. Just use higher resistance till 2k ohm. So if you put higher resistance like up to 2000 ohms, you should probably get same results as I, but it depends on your coil size. It depends on your transistor which you use in the system. I'm actually using in my circuitry MGL transistor, and it's very better. It's a very good transistor, even better than other transistor which somebody advised to use in the type of circuitry. But the system should work like this. I mean, if you go to the advanced level, of course it will be even better, because in advanced system they are actually using 7 transistors. They are actually using some sort of capacitors, they are using additional coil. With additional coil they are getting even more current and voltage, even more impulses, and they store these impulses in the capacitor, and then they discharge the capacitors, and system runs pretty well. I should mention at the YouTube channel from Mr. Aaron Murakami, there you can find videos with a more advanced system, where they're showing you more advanced system. But for me it's like I should complete this simple charging procedure, and from this I should just derive to the direction which I want to go. And my idea is actually to build and develop some automatic system which just switch the batteries and do it in very intelligent and tricky way. And I'm actually thinking more how much transistors I need to spin this wheel at the highest rate possible, because then I will put on the wheel some fan. This fan will produce wind power. This wind power will influence a windmill with a DC electric generator, and then when I measure this DC electric generator running, when I get, for example at that level 26 milliamps and the 12.70 voltage, then I just change the primary battery and put my running DC generator. This is a simple idea. I don't know how it's actually will be implemented, but if I have some wind power from the Bedini and I utilize this Bedini power through windmill which is connected to the DC generator, and the DC generator produce the voltage which is needed to sustain the system for the continuous running, then it will be very interesting. But always one question arises: what happens to the charged battery? Because at some point you need to disconnect the charged battery, because the level of the voltage will get to the point where it's at maximum voltage level as possible. So some problematic things are arising actually, and you need some advanced system which will be just monitor the voltage of the charged battery, and when the battery is fully charged, the system should take two options: switch to another charging battery, or just disconnect the system and stop running the system if this condition arises. But it's not easy to think about this, because I need more knowledge about microcontrollers, things more complicated, which I shouldn't mention here, but I tell you the idea, and you're free to use my idea, because I want to see more powerful Bedini system running and getting actual work from the system. And this is actually what I love to see, if somebody have enough resources to actually build such system. Another question and interest lies in the systems with more than one coil. I saw some videos with people who are using Bedini with a lot of coils, and I should tell them that they should connect me. Sorry guys, I'm pretty overwhelmed currently, and yeah, I'm just bubbling through, and I'm telling you, just take the experiment. It's not so difficult, but all difficulty can be in your wheel, in your transistor, in your batteries. And you should, for this experiment, for the first time, I should recommend that you will use only new batteries. If you use junk batteries and expect from them to get some result, I should tell you, prepare to be disappointed. And this is a normal learning curve in such type of experiments. And yeah, it's like this. It's like this, and you see that the voltage level did not increase yet, but maybe now it will increase. Does not happen. I don't know. It takes time. It takes time to move these ions. But on the other side, see that 12.70. So I have my current consumption. So it's not an over unity system, but it's very efficient system to charge your battery. That I should mention. Okay, now you see how my battery trying to push voltage to higher level. It always happens not rapid, but now you see 12.15, 12.16. So it takes time to charge the battery to that level which you expect, but this not happens automatically with a one transistor system which I have currently. And for the people who are having more transistors, I should expect that the charging level is higher, charging rate is higher, what I mean. And when they have highest charging rate, then they should actually run and charge pretty fast. But just keep in your head that if you charge the battery with very fast charging procedure, then it is possible that your battery are already defect or already won't work as you expect, because you do not expect with such type of charging systems that your battery will charge it pretty fast. It can be it need to be observed by the experimentator, and then the experimentator should discharge the battery appropriately many times. And what I'm actually second goal which I'm actually await, I just wait that when I get here fully charged, full charge on the charging battery, I hook up my inverter to the charged battery, then to the inverter I hook up the conventional charging device, and I will try to charge the primary battery which was previously discharged by the work when the battery was connected to the BDNI. So these things will be very interesting. And I should mention that I will put such charging procedures on my tape too, on my channel too. I want to share you some practical stuff which you can actually use in your experiments. But anyway, this is my information for today. Thank you all for watching this, and I wish you all the best. Bye bye.